Hello everybody, I'm Alexey Kravov, the organizer of SF Scala, and today we have the first joint meetup of SF Scala and SF FinTech. So SF FinTech is the new meetup. The full name was San Francisco FinTech and Blockchain Developers, and developers is the key word. So we are basically an overlap of developers using functional programming and other technologies for FinTech. And the first inaugural event today, we're very lucky to have Yaron Minsky from Jane Street Capital, which is a New York trading firm, and Yaron is a well-known person in the world of OCaml. Jane Street is based on OCaml, right? And so I'll let Yaron introduce himself and tell us what he does at Jane Street. Welcome, Yaron.
Thank you so much. So I've been at Jane Street for a long time and done a bunch of different things since I was there. I was the person who is, roughly speaking, the one who's responsible for the decision to bring OCaml into the company and kind of helped create that as the kind of core development platform we use for building all of our software. And in that time, I helped found the quantitative research group at Jane Street, and then I moved on to focus on software of various kinds, doing a lot of work in trading systems. And these days, I spend a lot of time in the tools and compilers part of the world. We have now our own kind of serious development tools and compilers group, and also continue to do work in the trading system space.
So for those who don't know much about OCaml, right? It's a ML type language, and Scala is very related. So as Scala is the biggest FP meetup in the world, I feel very responsible for other functional programming languages. So we regularly host Erlang folks and Haskell people. So we kind of think that Scala is the language which really made it big time in the industry, and so. But I think Jane Street is the most successful company using OCaml. So can you tell us a little bit why OCaml works so well for Jane Street?
So there's a number of things that make OCaml work well. I think one of the most important things is in general, the ML family of languages sit in a kind of sweet spot in the space of programming language design, in that the type system of a language like OCaml is relatively simple to understand. It's relatively straightforward to use, and at the same time does a really good job of catching bugs and preventing errors and allowing you to express invariance of the program in terms of the type system. And this whole business of writing software that trades on the markets is thought about correctly, terrifying. Right? You are writing anyone who's a programmer understands how easy it is to make mistakes, and the idea that you could write something which both can connect to the markets and make big monetary decisions and has access to your wallet, like you should be afraid of that. And so we think OCaml does a lot towards helping us build really reliable, believable software. And to do so relatively cheaply, right? It's a real force multiplier in that it lets you automate away a lot of the kind of mechanical checking that you would have to do by hand, and do it in a much more scalable way. So I think that's kind of the core of why it's so valuable to us. Another thing that I think makes OCaml really good is a very wide spectrum language. It's usable for little tiny scripts, and it's usable for large scale programs. So we run a tight ship. We have a fairly small number of developers. Jane Street has 600 employees, maybe 150 developers full time. In that, maybe another 100 people who program as a significant part of their job. But
substantial.
We build a huge number of systems. We trade in countless different exchanges, countless regulatory regimes, huge amounts of complexity in the systems that we build. And in order for that to scale up, we need a language that really maximizes the reach of each individual programmer. And by having one language that crosses a variety of domains, it makes it possible for people to reach into all different parts of the system. And one last thing is, you can make it go really fast. We write OCaml programs that can take down 5 million messages a second and consume and emit a packet in 5 microseconds or less. You can write really extremely performant OCaml code. It's in part has to do with really understanding how to use the language well, and in part just has to do with the fact that the language is understandable. The runtime is relatively simple. The language itself is relatively easy to understand its performance characteristics. And so that's all very valuable.
So I think you mentioned that you introduced OCaml to Jane Street in 2002?
Yeah,
around
that's
the time.
about
So
right.
that's longer than, for instance, like Scala started in 2006. Right, so like this is really a lifetime, right? Like a lot of companies did not exist. Facebook did not exist in 2002, right? So Google was kind of up and coming. So I'm very curious. So you observed the evolution of OCaml. First of all, how did you become interested in OCaml in the first place?
So I learned about OCaml as a graduate student. I was doing, my background is not programming language, it's distributed systems. And I was building prototypes, at first in Java, because that seemed like a reasonable language to do things in. And it was just too painful. Like I remember at some point, I built some little clock synchronization algorithm, and I wanted to spin up 200 copies of the program to kind of communicate with each other on my box, and like the box basically just fell over because of the huge amount of memory required for each instance. And there were other people, you know, some of my office mates who had been using OCaml, and I learned it from them and tried it out, and I was kind of hooked from that point. It's so lightweight, you know, and much more concise, much simpler than writing Java in many ways. And so I kind of started using it from there, and I brought it into Jane Street roughly by mistake. Like I didn't mean to. When I started doing some stuff at Jane Street, it was very early in the history of the company, just a couple of years in, and I didn't think I was staying. I thought I was going to go off to be a professor. And so I approached the work I was doing as research code. It's all throwaway. I'll get some results. I was doing statistical research on trading strategies at the time, and 80,000 lines of code later, it turns out I wasn't going back to be a professor. And we had this OCaml code base, and we started using it from there. And it was a few years in 2005, where we really made the decision to start experimenting with building our production infrastructure in OCaml. And you know, that worked out well, and we built our first trading systems in OCaml, and that initial project was very successful, and kind of the rest is history. We kept on using it to build out new things and replace old infrastructure, and kind of from there it became the foundation of how we approach the process of building software.
Do you have engineers in New York, or do you also have them in London and Tokyo and other places?
We have 3 offices, one in New York, one in London, and one in Hong Kong. And we have software developers in all of them. I think one of the reasons, I think software is fundamental to the kind of work that we do. People sometimes ask, are you a trading company or more of a technology company? And my answer is we're a trading firm, but trading is a fundamentally technological business. And everywhere we have people actively thinking about monitoring trading, we need to have the people who understand those systems deeply there as well. And so it's really important to us to have serious development groups in all of the offices. And also it's a place to find talent. So.
Yes. So can you characterize Jane Street as a high-frequency trader?
No. So I don't think there's anything wrong with high-frequency trading, and some of the strategies we do depend on low latency, and we certainly build infrastructure of that kind. But it's not the heart of the business that we do. I think we are, maybe more than anything else, a risk-taking organization. Like we are liquidity providers, and providing liquidity means taking risk, means that you have to hold positions. In some sense, if you think of like someone who sits in the middle, a middleman, if you run a grocery store, you're a middleman, and the thing you're doing is you are connecting buyers and sellers across time and space. Right? Not everyone wants to go straight to the farmer to buy their tomatoes. It's more convenient to go to your local grocery store who's like kept the inventory there available for you. And for that work, they earn some money from the gap between the price they're able to buy and the price they're able to sell. We do very much the same thing in markets, but more than moving things through space, which we also do, we're often moving liquidity across time. And that involves taking risk, right? At the close of the markets, people demand a lot of liquidity, and we want to be on the other side of that. We want to be able to supply liquidity to people who are demanding it, and that means we hold lots of risk overnight. So the kind of liquidity provision and risk taking is a fundamental part of what we do, and that's often less of like often the true high frequency firms are doing very small trading back and forth and try and go home flat at the end of the day, and that's very far from the kind of trading that we do.
So is it true that, again, I'm kind of relatively new in the space, is it true so then the market maker should be as agile as a high frequency trader? Because eventually they're all trading on a platform, so you should be a little bit ahead of most of the traders, you should be really fast. Is it a fundamental requirement for the market maker?
So speed has always been a part of trading. Like when people were trading down by the buttonwood tree, where in the old New York Stock Exchange, getting information more quickly than someone else mattered, and there's always some temporal component to trading, but people can provide liquidity at many different time horizons. So I think it's not the case that people sometimes imagine the only kind of market making is high frequency trading, and I think that's just not true.
Interesting. So I did my whole PhD essentially in multiple functional programming languages. I kind of used this opportunity to learn Haskell and Scala, but I actually ended up with OCaml. Right, so I ended up, I think, in the sweet spot because, and I was doing this from about 2008 to 2011, and when the crisis happened, right? And I interacted with a lot of folks at Jane Street who contributors to open source. And at some point I was worried that, the financial crisis, like, is it going to bring down Jane Street? Where are all these people who are providing this beautiful open source? Like, what's going to happen? So I asked them, are you guys doing all right? And they told me, we're doing beautifully. Like, this whole crisis for us is a good thing. And essentially, I got the feeling that because of this risk-taking, because of being smart, so I wonder if you can talk about it, how the fact that, you have all this code bases in OCaml helped you, if it did, to weather crisis like 2008? Are you is there any kind of way it helps you be prepared and change strategies? Is there any connection between the technology use and your ability to weather crisis?
So I think, without saying anything about how we did in any particular circumstance, I think we're liquidity providers, and in situations where there's lots of risk in the market, it's harder to be a liquidity provider and you're paid more for the service. And I think that is a kind of dynamic of the business that we're in. I think the stability and flexibility of the software that you write is essential to doing the business well, and it's especially important when things get very busy. Right? It's just as a simple matter, having software that doesn't fall over when things get busy is important. But also having software that can adapt quickly, that's reliable, that you understand its behavior, that you're confident it's doing the thing you expect to do, helps you do a good job of providing liquidity even in turbulent contexts.
Do you deploy more often, like some change happens in the market, do you find like you need to deploy software more often? And does OCaml allow you to kind of deploy it faster?
So I'd say as a general matter, we are very leery of deploying software in a hurry. Again, I think one of the core issues when you think about software and trading is it's a dangerous business. You want to be very careful and deliberate in how you roll out software. And when we have especially busy and important times, we're normally just like more careful and more conservative about what we do. I absolutely think a language like OCaml helps you move faster. In some sense, anything that gives you confidence in the correctness of your code makes it easier for you to make changes more quickly, because you can have more confidence that the change you made is actually right. And the stakes are very high, and so you really need to be highly confident about the software that you build.
So you basically were thinking you were going to go to academia and be a professor, but you ended up being on Wall Street, right? So I'm very curious, how do you reconcile these two cultures are, I think, orthogonal in terms of secrecy, right? Academics like to share. They like to kind of talk about knowledge, and Wall Street is extremely secretive and siloed, and so when I bring together communities, I want to build a conference, I find it's very hard to make people talk about stuff and share in general, right? So do you find that it's an obstacle to progress if we have this kind of highly evolved silos? Which are kind of so well funded they can hire, like basically they think they can hire all the people and do inside what they want to do, but wouldn't, is there any way essentially to talk about this stuff, right? To talk about research, or is it just bound to be like this?
So we take the sort of kind of trade secret aspect of the work we do seriously, and there's stuff that we think of as important competitively that we're very careful about how we talk about it. But we also try and be enlightened about the way in which sharing information can make for faster progress. So internally at Jane Street, we try and do a good job of being very open so that if someone needs to understand something in order to do their job better, they'll generally have access and be able to understand that thing. And when interacting with the outside world, we're actually, in many ways, quite open. We have published an enormous amount of open source software. Roughly 10% of our code base is available on GitHub, which I think is a very high percentage for almost any company.
It's a lot
to have. Any company that's not like purely doing open source stuff that has some amount of proprietary work, that's a really big chunk. And we've done a lot in terms of talking about the software we build and the ways that we approach and the libraries that we've constructed. And so I think we've actually had a lot of very productive relationships with people in the outside, people in the OCaml community, people in the academic community, other people in the functional programming world. So I think in some sense the conflict is less extreme than it seems like. I think if you take an enlightened view and think, and don't just like reflexively close off everything because it's information and therefore any leakage of information is bad, but you really think, what are your kind of core competencies? What are the things that are really important to you that you really want to keep private? And for things that aren't like that, you can engage in more sharing, and I think it's both satisfying to the people at Jane Street. I think a lot of people who work at Jane Street on the software side really like being able to contribute to open source in a serious way. And at the same time, I think you get a lot out of it. You get better interaction and feedback on what you do from the outside world, and you get to learn things from things that other people have done.
I think, I mean, like from my experience surveying the space, you guys are one of the most advanced, right? Because you both have open source and you talk about it. Some companies put out open source in fintech, but they don't really talk much about it. It's very hard to get speakers. So I mean, I commend you guys for this. That's really great. And I mean, you do a lot of talks which are very highly rated, right? Like I think like you do a lot of advocacy for functional programming. Which is really valuable and it applies across the space, right? So that's why we're very happy to have you, at the Scala, because I think the principles are the same essentially. So it's a question about the OCaml ecosystem, right? So I kind of found this very interesting. I had this very interesting feeling when I, was doing OCaml, being a graduate student, because I didn't really have the time to like learn all the newest hype and I didn't want 10 JSON libraries. Because then I would have to figure out which one is the best. It seems like OCaml is in a very sweet spot. There's one library for everything, almost. And it's like it may be done by a French guy in Tokyo who's been like doing it for 10 years. But you know for sure that you're gonna ask the questions, he's gonna reply, he's still maintaining this. So it seems like a very nicely slow moving space where it's like most bases are covered, right? And so there is like the scarcity of choice, which with distractions. So the pace of change is relatively slow. And I don't know, is it because it started as a kind of French academic project, which it still is, right? But I wonder, what's your feeling in terms of OCaml ecosystem?
So one thing I'll say is I think that is in some ways an out-of-date view of the ecosystem. And I agree there are some good aspects to the kind of slow-moving piece, but actually the pace of OCaml development, certainly of the core compiler itself, has massively increased. In the last few years. There was a period, maybe a decade ago, where things almost stopped moving, but there's been a series of changes, some driven by us, a lot driven by not by other people. And it's no longer the case where there's just one JSON library. Now there's a bunch of them, right? I think that there's a bunch of energy has gone into the kind of packaging and distribution story. So it's much easier for people to publish packages, so there are more of them now. I think it's still smaller than, say, the set of packages that you find in, say, the Haskell community, which has lots and lots and lots of little teensy packages. And I do think, the dynamic you described, there being fewer packages but on average of higher quality, I think is right. But I think the language itself, I think it has been moving much faster of late, but it definitely picks up advances later, which I think is both good and bad. So one nice example is type classes, which are a great feature. Haskell has had it for 20 years. And there are some fundamental issues with the way Haskell does type classes. Like you talk to the people who kind of are at the heart of the Haskell world, they have some complaints about how type classes are built. And OCaml is in the process of getting what are effectively type classes, modular implicits. And it's 20 years late, but it's a more principled and cleaner design than you find in other languages that got the feature earlier. And you see this in a number of different spots.
Interesting.
So I think OCaml has, the language features have moved forward at a kind of deliberate pace, but with making really excellent and high quality choices. I think this wasn't always true. I think there are some features that got in early on in the language, which I'm less excited about. I think the object system, I'd be mostly very happy to live without. And basically, in Jane Street, you more or less live as if that didn't exist. We basically don't use it.
There's almost everybody else, right? The O is there, but
the O is there. It was, I think, in some sense, the O was there in OCaml because in the mid-90s, to be cool, you had to have an object system. And if you look, in many ways, it's like a beautifully designed system. It's just not. It's not so much that it's a bad thing to have it in the language as it's kind of an attractive nuisance, which is to say, in ML, objects are almost never the simplest way to do things. They're a kind of high-level, advanced power tool. They should be used occasionally in fairly rare circumstances. But if you come to OCaml from an object-oriented language, you see objects and think, oh, that's the natural thing to use. And that's just a mistake.
Right.
You should go to them last, not first.
Right. I mean, Scala is an object function language, but I noticed I think the main use, at least for me, for object system in Scala is it's packaging things. I think it improves the syntax. That's why I like Scala for expression, because it lets you basically use its object system to glue things together, right? Because you have object.method, which then you can omit the dot, and you have syntax which looks to some people more like math than Haskell or OCaml. Although to other people it looks cleaner, if you did a lot of Haskell or OCaml or ML, right? So, but I think it's not a primary feature which functional programmers use in Scala in terms of the object system. So you mentioned Haskell. Obviously, that's another language which is very much up and coming in the fintech world, right? So there's a lot of banks using Haskell. There is a lot of interest in, so we had this conference called Scale by the Bay, which used to be called Scala by the Bay. We kind of called it Scala E by the Bay last year. Now it's Scale by the Bay because we always covered more languages, right? We like functional programming as a core of this, but mostly as a synonym for thoughtful programming. So functional programming used to basically, I think it's still this kind of the main foundation of thoughtful software engineers, and they can express themselves in Haskell, Scala, OCaml, F#, and we have folks who did Scala and now they do Haskell in well-funded startups, which I didn't see before. So I see multiple Haskell-based startups coming online, and so how do you see kind of the relationship between Haskell and OCaml in fintech and wider? And I'm just curious about your thoughts on that.
It's an interesting question. When you look at the kind of big industrial adoption of OCaml, most of the ones I see are outside of fintech. So Facebook has a very serious OCaml effort, significantly bigger as far as I understand than the Haskell work it has, although they have Haskell stuff as well. There's this very cool Haxel language that Simon Marlowe and various other people have worked on.
Right.
But there's a bunch of major OCaml projects there. Things like Hack, which is a programming language. It's basically an extension of PHP with a gradual type system. Flow, which is a similar effort for JavaScript. Infer, which is a set of static analysis tools. Reason, which Reason, which is essentially a kind of alternative syntax and toolchain for OCaml. And in fact, interestingly, something like 50% of the JavaScript code in Facebook Messenger is now derived from OCaml.
I'm very excited about this because I cannot bring myself to learn JavaScript, so I'm waiting for it to outlast something, to basically outlast it. Objective C is outlasted by Swift, so Reason seems like a good way to do full stack programming.
Yep. Yeah, I mean, and because you can use Reason, but you can also use OCaml. It's just a different syntax for the same core language.
But that all integrates with React and everything else. Are you guys using Reason?
I think the interaction with React, in some sense, I think should be orthogonal. Right? Again, Reason is primarily like some alternate tools and some nice kind of integration and all of that, but mostly an alternative syntax.
But it's done by the same group which does React, so it should work together. This is going to work together because it's the same people.
Although just to be clear, anything that you compile in Reason always works with other OCaml because it just compiles down to, it's just an alternative syntax. So you have guaranteed full interoperability between OCaml and Reason.
Are you guys using anything like this for your UI components?
We don't use React. We have some similar stuff some stuff that's kind of similar in principle, but instead of using the React model, we use a different incremental computing library that we have called, appropriately enough, Incremental, for doing the optimization. In some sense, every time you have a UI toolkit, part of getting a good UI toolkit is coming up with a clean way of expressing the logic of the UI, but a large part of it is just optimization, making it actually perform sufficiently well. And when you have changes to the data, the changes to the state, not having to recompute everything. And there are different approaches to that. React has one particular incrementalization approach. Elm is another language that has a very similar story for how the incremental computing stuff that's kind of built into it. And incremental is a fairly different one. It's based on a thing called self-adjusting computations, which is some research that came out of CMU, a guy named Umutakar, which is in some ways richer and more powerful optimization system, which, there's some trade-offs. You have to live in a monad, which not everybody likes to do. but it gives you more optimization power so you can build richer and more complicated dynamic views, which is important in a financial context because the UIs you build are all about fast streaming data and sometimes very large, always changing data sets. And being
Are your
able to
traders, do
efficiently
they
present
live in
them.
these UIs? Do they actually use them to execute the...
And I think the UI they live in more than anything else is Excel, and we have lots of nice integration into Excel as well. But yeah, there are a lot of these UIs that are increasingly central to the traders' workflows. In fact, the system I'm going to talk about tonight, I'm not going to talk about the UI piece, but there is a web UI for it that is built using exactly this incrementalization framework, and that is absolutely fundamental to the way a number of the different trading desks operate.
Interesting. So I think we're kind of coming to the end of this interview, so I have only got two questions for you. So one is, we have a lot of folks who start to do machine learning in functional programming. So Scala is increasingly used for data, right? And so although we're kind of in the time when Python is dominating data science, right? A lot of people learn Python first. So I have a feeling that languages like Scala, Haskell, OCaml, they are going to be very successful in machine learning going forward. And I think what you do falls under this umbrella because essentially you're using machine learning in data mining to make decisions, right? Which actually affects millions of dollars. So I think you're one of the mission critical applications. I wonder if you have any intuitions as to why people who do machine learning should look at functional programming, even if they don't know about it, right? Because most of them start in Python right now, coming into data science. What is it, about functional programming which can make kind of machine learning easier, better, more reliable?
So a couple of points. One is it's worth saying, like we've been doing kind of statistically driven machine learning style trading strategies for a long time, but actually that's not like the kind of core of what we do. I think the thing that James is probably best at is a kind of rich integration between human intuition and interaction and the kind of quantitative understanding that you get from having a good mathematical understanding and a good game playing understanding of how trading works. So I think people often imagine where it's like the whole place is just about building models and watching things trade and not having this kind of deep human interaction, and that's just not true. Where the human part is incredibly important to what we do. That said, we do a lot of statistical analysis and machine learning style techniques. Indeed, that's the first thing that I did when I started was working on that kind of stuff. I think functional programming, in some sense, I mostly don't think of functional programming as a special purpose tool. I think ML is an incredibly good general purpose language, and it's good for a wide variety of different techniques, and machine learning in some sense just fits in a very natural way. Here's like one simple story about the ways in which these kind of, in some sense, very ordinary benefits come up in machine learning context. So we also use Python and R and other things for doing data analysis, but we ended up with a OCaml wrapper for TensorFlow, in addition to using a Python wrapper for TensorFlow. And one of the things we discovered was it was really nice to use the OCaml version because sometimes when you use the Python version, you'd set up your model and you'd go off and do the compute intensive part of it, and it could take a long time. It could take hours to run the analysis. And then you'd run it and then it would blow up for some completely stupid reason that you could have caught at the type system level.
Yes.
And when you have these kind of compute intensive jobs, it goes to the old story of like you want to catch errors as early as possible. And that is true in all sorts of software circumstances, but it's very much true in machine learning, just from a kind of pure efficiency point of view of getting stuff done well, just having more confidence that the thing that you set up is actually right before you spend 3,000 compute hours on it is super valuable. I think there's lots of benefits of that kind. I think the type system is valuable, and the kind of freedom of flexibility that you get from the kind of easy, lightweight, higher order programming that you can do in a language like ML, it's just all very valuable.
Is that OCaml wrapper open source?
Yes.
Nice. Thanks for mentioning this. I think it's I think it will be very interesting to play with that. So the last question I have is, you guys are contributing a lot of stuff to the community, right? What do you want to see from the community, right? So you give a lot of open source. Like, do you want to hire smart people? Do you want people to help you develop OCaml ecosystem? What are you looking for from the community to help you with in the OCaml ecosystem?
So all of the above. So we definitely do a lot of hiring, and I think these days it's no longer, there was a time where the majority of our hiring early on, certainly the majority of my personal hiring came out of the OCaml community, and now it's much more diverse than that. But I think we still get a lot of benefit from hiring people who have experience directly there. I mean, we hire lots of people with no functional programming experience at all, because it turns out it's not hard to learn OCaml. For smart developers, learning a new programming language is just not that big of a deal. But still, hiring is an important aspect of it. And I mean, we have a lot of collaborations with people on the outside to work on, there's external libraries that we depend on, and we're always very grateful for that kind of work. There's tools. So one tool that we're really excited about and happy about is a tool called Merlin, which gives essentially IDE-like functionality for OCaml, and we've been using it for some years now. And that was not something that we thought to develop. It was something that other people thought was important, and they created, and then we realized was valuable, and we started using. And in fact, we've hired since then one of the developers to actually work at Jane Street, but it was created from the outside. I think there are lots of good ideas, both at the level of what libraries to build and also at the level of developing the language itself, that come from the outside, and that's an enormously rich and productive interaction there. So this is in no way a one-way street. I think I like to think that we provide a lot of value, but we also get an enormous amount of value from the OCaml community, and to say a straightforward thing, from the team that develops OCaml. We have started recently putting more of our own people working on the compiler, but the compiler is by and large the work of people who do not work at Jane Street, and we are enormously grateful for the extremely high quality of engineering and the good design and the good taste with which it continues to be evolved. I think the most important thing that the core compiler team at INRIA does is say no. We've said no to lots of bad ideas and kept OCaml a tight, beautiful, well-designed, easy to use, easy to learn language. And I almost never look at a new release of the compiler and think, oh, that seems like some piece of garbage I'm sad about. Right? The things that are added are almost always well thought out, sensible things. And sometimes when I think they're not interesting, I'm just wrong. So for example, when GADTs were added to OCaml, I had no idea what I wanted them for. It sounded like the kind of nonsense you get when you allow people who write compilers, you let them design a programming language and they build things that are nice for their problems, but I'm a systems programmer. Right? But it turns out GADTs are great for systems programming, and it's been very important for a lot of the systems that we've built in a way that we totally did not expect.
Interesting. So, I mean, I think I must say that this is really exciting to hear that basically, you have this global company trading, and like you go all the way back to the compiler, which plays a key role in that. That's really exciting, for like as a PLT geek to hear that. So we're very happy to have you, and we're looking forward to your talk.
Awesome.
Thank you.
Thanks.